Hi, one of the audience, he wants me to reverse his Sprocket cover. He gave me some information other than the 3D scan that he made with the Creality Scan Otter. Send me two scans, a front and a back part, and he tried to merge them together manually using a cloud compare. Okay, here's what he explained and what he wants me to focus on: the mounting point and the recess. So here thickness 5 mm. He also provide a thickness for the flank. So I try to make a 3D printable version of this the cover. Actually, if you can give me a full scan on both sides, you don't even need to give me this, especially from the Raptor. But for the Otter, it's has a lower accuracy, and the sharpness of the scan is not as good as the Raptor. So I need to see the photograph. They have a stiffener 2.4 mm. Okay, let's get started with his scanning data. He also sent me the project files, but I couldn't open it, probably because he saved it in a different time, the project files and the project folder. He also sent me a mesh. They've been aligned together on the outside and the inside, so I will just drop it to the cloud compare. Okay, here's the first mesh that he made, and this one will be the inside. The inside and outside has already been aligned, but from what I can see, he didn't align it properly. A little bit of the plane shifting. For scanning a thin shell like this, you need a complete data. All the side walls, even the small thickness of the wall here, it has to be scanned so that you can get more overlap area for merging. And I recommend that for a pocket and crevice like this, you need to use a spray, get a more complete surface. So next step, I'm going to convert this into the point cloud. Because if you use a mesh for reversing in CAD, the mesh will consist of edges and faces. It will block you from seeing the edges and the wall. So the best practice for reversing is to use the point cloud. A major CAD software, most of them can import the point cloud for reversing. For example, SolidWorks, Inventor, and Rhino. Okay, next step, I'm going to convert this mesh into a point cloud. Click on Edit, Mesh, Sample Point. I've used 300,000 point for one face. Mesh, Sample Point, 300,000. Now we have the point cloud. Actually, if he sent me the point cloud, that would be the best, because point cloud from scanning is a raw data. The software has not applied any smoothing, so you get more accurate dimension from the point cloud than from the mesh. So if you mesh it, not only that, it will give you more difficulty when reversing. It will reduce the accuracy of the scan. Save it as a LAS files. And then I will convert it to RCP format, which is recognizable by Autodesk Inventor. Okay, here's the finished part that I have already modeled with Autodesk Inventor. In this video, I'm going to tell you the workflow that I use for creating this part. This part is built by using only 3 commands. One is the extrusion, second is the loft command, and the third one is revolve command. So there is only 3 functions. Reverse engineer is me create the model by using the same command that the original designer used it for modeling this object. First step, I'm going to make the first extrusion by making a very thin cut of the point cloud. I cut the point cloud here. I get the first section of the point cloud. If I look from the front XY plane, you see that I can trace the line for the first profiles that I need to do. Here's my first profiles. You can see I trace it along the wall, close profiles, and then I extrude it for 5 mm. Okay, next step, I'm going to create a second profile for lofting. New sketch is created on a new plane because this object has slightly angled plane here. So I use point to snap on the point cloud for 3 points and create a plane to to make a sketch over this plane, and this sketch is similar to the first sketch. I trace it along the profiles of the point cloud, and then I use the loft command to loft the two sketches together without using the rail. Okay, next I'm going to create this sphere dome here. So now I love cutting it with the two sketch, so it will create like a circular chamfer pocket. Next step, I create a 2D and 3D sketch for making a revolving axis. Because this plane is not level, I create a sketch for making a sphere. Okay, here's my first revolve. Create a new sketch here for the second revolve. Right, it looks like a pie. And next, I use a chamfer command to make a cut. And then I fillet the corner. Next step, I extrude here for about 3 millimeters longer because the first profile that I made was too short. So now we have a solid. The original object is hollow. It's a thin shell object. I'm going to use a shell command. Okay, here's a shell command. A shell command allowed you to convert the solid into shell, and you can remove certain faces. Like this one, I remove the bottom face and one face on the right here. So I use 4.4 millimeter for the thickness of the shell. Okay, in the front side there is a pocket 1 and 2 here that I need to cut. So I use a sketch and trace it with the point cloud and create this cut. And then I use a fillet command. I create a sketch by tracing along the point cloud, and then I cut it. And next, I'm going to give an extrusion from this imprint. See, extrusion from the inside. And next, I do edge chamfer. I also make a chamfer here in the front, because a chamfer is 45 degrees, right? So it's easier to print. Okay, next step, I create a plane using the point cloud as reference. Okay, so I create a sketch for the stiffener, and I fillet the corner here. And then I use array command to clone the feature that I just made. Okay, I do the same here. Create a sketch for making a stiffener. And then I use array command to do a polar array. There will be a 6 number of the stiffener. So here, the final one here, final stiffener. I make a chamfer in the front here to make it less sharp and easier to print. Okay, I create a sketch for the extension in the front. I make extrusion for 5 millimeter. I use a chamfer command to create profiles. The bottom plane here is not level, so I create a new cut using the plane to slice the sketch and cut it. Okay, next I create two sketch here for the bracket, and then I extrude it, and it has an inset for the hole. Okay, I create a sketch for the second hole, and this one, the hole diameter is 9.5. It is smaller than the other side. Okay, they have an inset as well, and they have a spigot. It's extrusion for the spigot. Okay, and now it's all done and should be ready for printing. If I print it like this, spigot here is going to be a problem. So, and it's required support. So I print it like this in a vertical direction. I think this will give a best result. Okay, so I drop it to the slicer. I'm going to use K1 Max for printing this. The workpiece is quite large. K1 wouldn't be able to print this. I put this face to the print bed, so I print in this direction, and I will use the 3 support and print with the ABS filament. Okay, now it's not clashing. Very exciting. Many times it will clash while I do a slicing. So there will be support on the edge here, and the surface will be rough. Slide it. So okay, let's send it for printing. 3 hours and 22 minutes. 86 grams of the filament. So when I print with the ABS, and I need good adhesion, I will wash the plate, wipe it dry, and apply fresh glue is PVP. You can use it a couple of times. So bed adhesion is very good for the K1 Max. Oh, that's easy. It's a little rough here. Okay, because I don't have the original part, let's compare it with the photographs from the viewer. There is a bump here. There's a bump here around the circle, around the edge of the circle to increase the thickness. I didn't put it there, so I forgot to draw it. And for the stiffener, I follow the original scan leader. And I think this stiffener is going to be sit on a machine because it's in the same plane. Yeah, the outside of the shell looks okay to me. There's a bit of the wave from the speed printing. This top part here is a little rough. Part that requires support is very rough, but we need to sand it out. Yeah, this looks quite alright. Okay, so this is the first reverse engineering project video that I didn't make a 3D scan. So if you want me to try reversing your scans, you can contact me by the email. Preferable a plastic part because I can test printing with the plastic and make a video to share with the other what the 3D scanner and 3D printer can do. Thanks you guys for watching. I'll see you in the next video.